Good afternoon, everyone, and I hope everyone can hear me well and see the screens as well. My name is Rahul. I am the co-founder and chief evangelist at V45. We are an application security focused company. Great to be here in B-Sides, Calgary. This is the second time that I'm here in a row. I was there in 2020 as well. I hope to have done this in person this year at least, but I know how things are, and I'm hoping to do this next year in person at the least, and fingers crossed from that standpoint. I know this is probably the second session that we're doing today on the same topic around threat modeling. I think I just saw another abstract by Jeevan who probably did this earlier in the day. I didn't get a chance to go over that presentation, but I'm hoping that this session here kind of adds on a little bit more perspective for viewers who've already seen that session. And there's something else that you can take away here in addition to what Jeevan must have talked about. If there are any questions, please feel free to kind of use the chat window, and I'll probably get to it at the end of the session. A little bit about myself, just before we start off. I have been in the domain of application security for the past 7 odd years. I helped co-found this company, V45. I've been in cybersecurity over the last 11 years or so. And largely, some of the things that really keep me up at night are things around application security, automation, tooling, threat modeling, and really driving programs from an AppSec perspective, especially with large customers, in terms of not just the technology side of things, but also the cultural and the procedural aspect of things, which often seem to be a big issue with transformation projects, especially around DevSecOps. So with that having said, so we're going to be talking about threat modeling in this session, but if there's anybody else in the virtual room who shares a keen interest in any of the things that you see up on the screen today, happy to kind of connect and chat more of the out of the whole session here, and look forward to kind of connecting well as well. With that, let's get started with today's session. Over the next 45 minutes or so, we're going to be looking broadly around the following things. We're going to be really looking about what threat model is in the current sense of the word, and not really from a logistical perspective, but really in terms of what it means at a fundamental AppSec perspective, right? We're going to be looking at a very different definition of threat modeling from that standpoint. We're also going to be looking at some failures in terms reasons as to why threat models usually fail as we know it. And more importantly, we're going to be looking at two distinct schools of thought from a threat modeling perspective. We're going to be looking at two very, very different ways of performing threat modeling from an AppSec perspective, and also going to be looking at a very interesting point of conjuncture from both these schools of thought that we've worked on, and especially which is proven quite interestingly successful in large-scale implementations as well. One of the ways to do that is an open source framework that we at the folks at V45 developed, called the Threat Playbook. It is out there in Git for everybody to download and use. We're going to be looking at that as well. And finally, we're going to be looking at how threat modeling in this new definition that we look at today seamlessly integrates with the security testing framework, or the automated application security framework that most of us are familiar with, and what is really the interesting points of conjuncture between threat modeling and security testing, so to speak. So we've got a couple of interesting things to uncover over the next 40 minutes or so. So let's get started. Before we start off with threat modeling, I think, and this is a slide that I have obviously changed with respect to the context of the presentation that I'm doing, but most of my presentations always start off with this initial screen that really kind of gives you a perspective or a context of where AppSec is today. And obviously, over the years that I've done presentations, I keep changing this depending upon the kind of customers that I meet, and the kind of strides that various customers have taken on. But largely, as we speak today in October 2021, certain things are absolutely, you can't ignore some of these facts. A huge increase in tooling and test iterations, a lot more testing, a lot more automation that's done, a lot more tools that have been gotten into the ecosystem. So there's this whole bunch of tools and test iterations that have been thrown into the AppSec pipeline. So definitely something that cannot be ignored. And we're also seeing very interesting feedback loops that have been implemented from AppSec automation standpoint. So what I mean by that is not only have we been fairly successful in terms of shifting left, as we probably say, but we've also been able to kind of shift right, interestingly. And what I mean by that is there's interesting feedback loop mechanisms that have been implemented where metadata from production systems, metadata from incidents that have happened in production systems have been used as intelligence back in the earlier stage of software development as well. So you have a lot of insights that you can now glean from incidents that have occurred and have not been prevented, but still you have that metadata giving you very, very interesting data for you to build your initial threat models as well. You're going to be looking at some of that as well. A lot of as code execution models. We obviously started off at infrastructure as code. We then went into security testing as code. And today we are at a point where we're also looking at threat modeling as code. So there's been a lot of strides that have been done in the as a code execution model. And threat playbook that we're going to see in a couple of minutes is one such example of how we've been able to kind of integrate threat modeling as a code. And all of this have obviously kind of integrated with mainstream SDLC. This is something that we've been saying in the application security world for the last decade. But I think truly in many forms than not, we've seen a lot of these things integrate with mainstream SDLC. I always say that the last decade, the decade that ended with 2020, was the decade that gave AppSec its prime time slot in product engineering. We got the 10 p.m. slot or the 9 p.m. slot in product engineering. So the way forward right now really isn't for us to be able to kind of scale that to the next level. And with the increase in tooling, with the increase in automation, with the increase in testing iterations, there's been a huge amount of data that's resulted not just in terms of traffic light indicators in vulnerabilities, but also in terms of metadata that these tools generate. So it's not just the data that we see at the face of the vulnerabilities. It's also there's a lot of information in terms of the story that vulnerability says, in terms of how was it found, at which stage was it found, what is the class of this issue. If there was a vulnerability that was found in a certain stage in the SDLC, what kind of strategic initiatives could that product engineering take based on the kind of data that they see. A lot more of information that we're now seeing through vulnerability statistics. So some of these things have been interesting that have happened as we see in application security today. When we get into threat modeling, one of the things that I always hear, and I'm sure this is the same with many of y'all here, is really things that people say about threat modeling. Right? There's a lot of castles in the air that have been built on threat modeling. You start doing threat modeling, you can completely eliminate all kind of issues in security testing when you get there. If you've not done threat modeling, then you've not done anything in AppSec. Threat modeling is really that utopian world that AppSec engineers need to be in, so on and so forth. And there's been so much that's been said about threat modeling. And to be honest, some of them are factually right. Some of them have the right motivation. But then the issue is, because of this overselling of threat modeling that's been done from really castles in the air that have been built by a lot of communities, when people start implementing that at ground zero, things are very, very different. And that's really why we see many of us meet with failures in implementing threat modeling as we deemed fit, as in the exact same and shape, in the exact form and shape that we've heard of threat modeling. When we try to implement that at ground zero, things are completely different. They either fail and they fail for multiple reasons. So let's look at why threat models fail. But before we look at why threat models fail, I think we need to ask ourselves the fundamental question of what really is threat modeling, right? If someone came up to me and said, can you define threat modeling? I would actually take a step back and say, it really depends on what the motivations of threat modeling is. And for that, for us to define threat modeling, I'd like to kind of always like to take the example of the blind man and the elephant and the fable that goes. There were blind men who didn't know what they were touching, and every person was touching one part of the elephant. So some of them thought it was something else, some of them thought it was a snake, some of them thought it was a horse or whatever it is. And from their perspective, that was right? Because that's the view of the world that that person has. And it's the exact same definition when it comes to threat modeling. And there's nothing wrong or nothing right with it. So threat modeling can actually be, if you ask a person in architecture, they would say that threat modeling helps them find issues in architecture and design. If it's a developer or a security tester, they would say it has certain countermeasures. It could be used to simulate attack vectors. It could be used to choose technology components. It could be used to ascertain the surface area of security testing in terms of coverage. It could even be used to anticipate security incidents in the past. But what's really interesting is all of this is true. All of this in today's world is possible through threat modeling. So when we look at the definition of threat modeling, I think one of the primary things that we need to ask ourselves is, why do we need to do threat modeling? And your definition of threat modeling, and when I say you, I mean you as a member in product engineering. You could be a developer, you could be a tester, you could be an architect, you could be a DevOps engineer, you could be a QA engineer, or it could be a release engineer, right? So it really depends upon what your individual motivation to threat modeling is. And that really is where the definition of threat modeling stems in. Just like there's an application security, there's nothing that's one size fits all. And threat modeling is also not a one size fits all. So one of the primary reasons why threat modeling fails is not understanding why we do threat modeling, right? And as we've seen before, and we're going to see in the next couple of slides as well, for one of the primary starting points of performing a threat model is to really understand why you perform threat model, right? So if you have a colleague or a friend who's in another product company performing threat modeling and has got good results, it does not mean that the same way that you perform threat modeling there would work in your organization, because the motivation of threat modeling there would be very different. It really depends on who's doing the threat modeling and why they're doing the threat modeling. And as we've seen before, you could do threat modelings, you could perform a threat modeling activity for things such as finding flaws in architecture and design, which is probably the oldest reason or the most common reason that you would perform a threat modeling, to something very, very contemporary, to really figuring out what the impact analysis of a security testing is. So the breadth and the horizon of why you would perform threat modeling in today's world is very, very different. So it's very important in terms of for us to understand what the motivation to perform the threat modeling is. There is no one size fits all. And that's the singular rule that is present in AppSec, in my opinion. Nothing is one size fits all in application security, and threat modeling is not unique to that rule as well. The second reason in terms of why threat modeling usually fails is an innately unnecessary overemphasis on how to do threat modeling. The moment somebody says, oh, I want to do threat modeling, the immediate follow-up question that comes to do is, what methodology do you use? Are you going to be using Stride? Are you going to be using Dread? Are you going to be using the PASTA framework? What is it that you're going to be using? Again, there's no right or wrong answers. The methodology that you use would once again stem from the motivation that you're going to be that you even perform the threat modeling, right? And one of the common reasons that most threat modeling fail is the team coming back to us and saying, oh, there's too much documentation. There's too much of methodology information that I need to factor in. Various questions like, what tool should I use, and why, what methodology should I be using? And there's this unsaid rule that threat modeling needs to be complex. So if there is somebody who does a back of the paper threat modeling, they would often question themselves and saying, am I doing the right thing? It doesn't seem to be complex enough, because there is this understanding that threat modeling needs to be complex and it needs to be documented in this hugely complex verbose form. And I want to take this time to say that none of that is necessary. It can be as simple as just a back of the paper. And I was just doing a threat modeling today morning. I just had the paper fall off. But I was doing a threat modeling today morning with my team for an application pen test that we're doing. And I'll actually show you. It's as simple as just scribes in a paper that I've done. This is literally a threat model that I did today morning. And all that it has is mind maps and sequence diagrams and tree structures of just noting down what the impact state, what the surface area of the application is, who the actors are, what the input and the output vectors are, and so on and so forth. It's not even, it's literally at the back of some random paper here. But the point of the matter is, it really depends upon what you're going to be doing with that threat model, right? So let's not worry about documenting the threat model first. Let's just worry about what's the advantage of us doing threat modeling, what's the way of threat modeling that works for us, and then we would document that, right? So it's very important that we do that. So with that having said that, I'm just going to quickly check if you're okay on time. Yeah, we're good on time. Having said that, let's now get into these two schools of threat modeling in my world, or in my kind of definition, right? It's not something that's this is not something that's there all over the world, or everybody else is prescribing this, but this is just purely my personal way of depicting this. In my view, there are two schools of threat modeling. There is the story-driven threat modeling, which we'll get into in a bit, and then there's a component-driven threat modeling. Now, the story-driven threat modeling, as the name suggests, is driven by stories of an application, right? There is an application. The whole threat modeling stems from a what-if scenario. What if actor A was to perform this action on application X, resulting in this impact Y, right? So it's really based on a what-if scenario. What if this were to happen? What if that were to happen? So you ask questions of pessimism from a security perspective, trying to kind of question the status quo of security of an application. It's really based on the what-if scenario. So that's the story-driven model. The component-driven model is what people are mostly used to. It's the way of us determining what the inherent weaknesses of an application is based off the components that are built for the application. So what are the kind of technologies, what is the technology stack of the app? What kind of programming language is it using? What kind of database is it using? What kind of hosted environment are they using? If it's a cloud-based application, what kind of cloud services are they using? So on and so forth. So it's based on the fact that the overall threat of the application is the sum of all the individual threats of the components that are used to build that application. So most of the threat modeling that we've done in the recent past is based on this school of thought. The cornerstone of a story-driven threat model are the abuse cases. What are abuse cases? It's the way that you would abuse a use case. Every application has multiple use cases. Every use case has one or more abuse cases. So the abuse cases are the cornerstone of the component of the story-driven threat modeling school of thought. Whereas in the component-driven school of thought, they are known issues of components. If you're using a component X, it could be a cloud service. Let's say you're using EC2 or you're using S3 or something like that. S3 and EC2s have inherent vulnerabilities. Some of them have been fixed, some of them have not been fixed. So it's all generated from that perspective of known issues of those vulnerabilities, of those components. Therefore, the story-driven threat modeling is usually used in a post-design and can be used even through development, because you are really kind of subjecting it to a what-if scenario. So even you could use the story-driven model even at a stage where the application is just being prototyped. It does not necessarily need to be used at a blueprint level. But the component-driven model is usually used in the pre-design or the design phase, because you're kind of really questioning the status quo of the components. So you want to be sure that even before you start using the components to build that application, you want to be sure that you're using the right components. So therefore, you use that much earlier in the phase. By extension of which, the story-driven model is used by the security professionals and the developer personas of product engineering, whereas the component-driven is used by the architects as well, in addition to the security professionals and developers. The focus of a story-driven threat model is on depth. Obviously, you're kind of questioning what-if scenarios. You're looking at business logic flaws. You're looking at edge cases. You're looking at multiple other things. So the focus of this school of thought is on the depth of issues, whereas that in component is usually more horizontal. It's more on scale and it's more on breadth. Examples of story-driven threat modeling. Unfortunately, you don't have a lot of tools that work on this. So therefore, you usually subject the application to manual methods, or we've used Threat Playbook, which is our way of kind of starting off that journey with this. Again, like I said, it's open source. Anybody can use it. It's there on Git. I'll send you the link as well. So Threat Playbook was our way of kind of saying, let's take that bit of story-driven threat modeling forward using some kind of automation. However, on the component-driven side, you have multiple tools. Obviously, this is a platform agnostic forum, so I'm not going to be using the names of actual tools here, but I'm just giving you hints here that most of the commercial tools that you've heard of and used are probably falling in this bucket of component-driven threat modeling, which is a great way to perform to achieve scale. So today, for the rest of the presentation, we're going to be largely looking on story-driven threat modeling, but just to give you a hint of what component-driven threat modeling looks like, is typically it's a very simple 4-step process. You have a questionnaire or a wizard where you would key in the details of the application in terms of tech stack, in terms of actors, in terms of, it's almost like preparing a bill of material of sorts. You kind of feed in all details of the application, including things like, is it subjected to any kind of compliance mandate, like a PCI SOC or a HIPAA or a GLBA or whatnot, and then you give all that wonderful information of the application to that system, and the system really kind of spits out a neat little diagram or a vector diagram or a map diagram of the various components and the kind of interaction that happens with these components from a data flow perspective or a process flow perspective. And then it would also list down the sets of threats and countermeasures of those independent or those individual components. So like we said, you have the ecosystem, you have the components laid out there, and then you have the individual threats and countermeasures of those individual components, and you would start working on them. So this is really the broad way in which most of the component-driven threat models kind of work on. Now, in the story-driven threat modeling, which is quite interesting, and that's what we would like to talk about today, we're going to be looking at today in the next few slides, is really the story-driven threat modeling. And the anatomy of the story-driven threat modeling is something very interesting. So it always starts off with a use case, like we discussed. Every application has one or more use cases, what is the functionality of that particular use case, right? So it's a simple functionality statement. And that use case would have an abuse case, which really is us trying to figure out what are the various things that can go wrong with that use case, right? What are the various things that you could abuse that use case, right? So that's the abuse case. And then the abuse case would then drill down into an attack model, which is how can that abuse case come to life in the if there are security engineers in the room. This is really weaponizing the use case, right? So this is where we are kind of taking our analysis or our hypothesis of the abuse case into something more practical, which is us trying to see how can this come to life. So there's the use case, there's the abuse case, and there's the attack model. These are the fundamental building blocks of the story-driven threat modeling. For example, a use case, let's say there's an application, and for the sake of conversation, let's say there's a user story where there's a search bar. Let's say it's an application where you could search for notes. It's a note-taking app. So as a user, you would want to, there's a search bar there, and you can search for your notes in that application. So that is the user story. The abuser story, there could be two abuser stories that happen to that. One of it is, as an abuser, I could search for notes that don't belong to me. Which means that I could search for somebody else's users, another user's notes, and therefore kind of steal potential information, confidential information, and whatnot. Or I could use the search functionality to kind of inject some kind of payload into the system and therefore have some kind of persistent cross-site scripting attack or something like that, where I could use it to steal a victim's credential or blah, 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 right? Something very simplistic. I'm not obviously, these are very simplistic examples, but just for the sake of conversation, right? So there's a use case and there are two abuse cases. Now, let's say if I want to exploit the first abuse case, which is that of trying to disclose sensitive information, I could do that in one or more ways. Let's say I could do that in three ways. In one way I could do that is using man-in-the-middle attacks. I could do that using injection attacks, or I could do that using a URL redirection scenario. Now, the man-in-the-middle, the injection, or the URL redirection are ways in which my abuser story would come to life. So therefore, I would call them the attack models. So this is an example of how one user story eventually translates to three attack models. So this is just an example, but it really has a 1:1 relationship. A user story could have multiple abuse cases, and each of those abuse cases could be exploited in multiple ways. So it's almost like branching out a branch out scenario where there is a use case that branches out into multiple attack scenarios. So I wanted to do a demo of Threat Playbook because we don't have so much time today, and I didn't want to, really kind of take up a lot of time. I've actually gone ahead and this link here that I would obviously the group of B-sides would share this presentation with you, and this would also be uploaded and recorded, I'm assuming. But this link here, if you're interested, is the GitHub link where you would find all the details of Threat Playbook, including videos of how you would use Threat Playbook and how does Threat Playbook fit into this model that we discussed. The entire thing of Threat Playbook is really a threat modeling as a code framework. It's built using Python, MongoDB, and a GraphQL interface. It's best suited for a story-driven threat modeling like we discussed. And one of the things that you could do with Threat Playbook is really kind of integrate a threat with a vulnerability in terms of an actual vulnerability that comes from tools. So there's interesting ways. What we've done is that we've taken an application, we've threat modeled it, we've run tools on that same application like a Zap or a Burp or SAST and SEA tools, which spits out a lot of vulnerabilities. And then what we've done is we've actually taken the threats and we've tried to map them with the actual vulnerabilities that these tools provide. So what that does to you is that you now have a scenario where you have your threats. Let's say there are 50 threats and there are 100 vulnerabilities. You can now say which threats resulted in which vulnerabilities, right? So for example, if there are vulnerabilities that don't map to a threat, that means that you need to improve your threat modeling process, because now there is a vulnerability that you did not factor for. So you need to go back and improve your threat modeling methodology. Now, let's say there is a threat that doesn't link to a vulnerability. That means you're in a good spot. You've envisaged a threat, but then your application is still resistant to the threat because you've not found a vulnerability. So that's a very interesting use case for us to be able to kind of link an actual vulnerability with a threat. And in Threat Playbook, it does that using CWE IDs, which really is what the tools kind of give you too. Now, let's look at ways in which threat modeling, as we've just discussed now, and more particularly the story-driven threat modeling model, how does that kind of integrate with security testing as we know it, right? So that's that's an interesting kind of a look that we've looked at in this section. So you remember the anatomy that we talked about earlier, which essentially is the use case, the abuse case, and the attack model. Now we're going to add one more step to this tree, and that step is that of test cases. So we stopped with attack model, which is how can an abuse case come to life? A test case is really testing that, right? How plausible are they? It's probably in a very unique way similar to the difference between a vulnerability assessment and a penetration test, if you will. A vulnerability assessment tells you what vulnerabilities are there. A penetration test actually takes those vulnerabilities and tries to actually see if there is salt to those vulnerabilities, right? So it's very similar in this case. The attack model tells you what are the various ways in which an abuse case can come to life, but the test case will actually test that. It'll say, okay, you say there are 50 things that can go wrong. Let's see whether they're actually possible or not. So again, let's go back to the same example that we saw of the search application or the note-taking application. We had 3 threat models or attack scenarios that came out of it. Now, each of those can be tested in these plausible ways. And I'm not going to go over these test cases because these are pretty self-explanatory. If there's a man-in-the-middle attack, how would you check for a man-in-the-middle attack? Like if there's an injection attack that's possible, what are the various security test cases that you would subject that injection attack to? It's a very simple thing. And the ways and means to do this is very different depending upon the pen testing agency, depending upon the processes that the pen tester follows. But in a sense, what we're trying to do is we're actually trying to see each of these attacks coming to life and actually testing them. So the security test cases really kind of give you that interlinking possible from a threat modeling standpoint. And when you have these test cases, each of these test cases that you see here, when you have those test cases, the link to automation is quite simple, right? Any test case can have 3 journeys possible. The first way that a test case would fall into a bucket is if it's 100% tool-based. that test case can be completely executed by a dash by a dash tool like a Zap or a Burp or an Nmap or a Nikto or whatever it is, right? Or a W3AF. So if a test case can be purely executed by a tool, I would call it a 100% automated test case. On the contrary, there are test cases that a tool cannot execute, right? It could be a business logic flaw, or it could be a logic bomb, or it could be an edge case, which requires the trained eyes and the skills of a pen tester. Now, if you have a test case like that, you could still automate that, and you would do that using automation frameworks like Cucumber, Selenium, Robot, and things like that. So just like how you build functional test cases using these automation frameworks, you would use the same means to build security test cases in a very similar form. And then you have the hybrid test cases, which means these are test cases where the tool takes you only so long, only so further, and then you would need a pen tester to carry them forward. So it's a combination of the tool and the script base. So things like parameterized dash scans, which means you're running Zap on a proxy mode using QA automation or functional automation scripts. So that's an example of how you would use the hybrid testing methodology. So irrespective of the kind of test case, you can automate it. You would either automate it completely to a tool, you would automate it using a combination of a tool and a script, or it would be automated purely using a script. Now, with this in mind, you could actually kind of imagine the whole 9 yards of how you could do this. So what happens is that you would essentially, there's a new feature that's developed. And if it is, so here's where you would use, and especially in large scale enterprises, you can't just use one of the two schools of thought of threat modeling. And what we've done is when we work with large financial institutions, we've seen that a combination of both of these schools of thought is what works best. So you would use the component-driven school of thought for you to achieve scale, and you would use the abuser-driven or the story-driven threat modeling to achieve depth. So every time there is a new feature that comes in, you would first take that application, the feature would be developed, you take that feature development, you run it through the component-driven model. So you run it through a commercially available threat modeling platform, and they would give you some kind of list of threats and countermeasures based on the components. So that's one flow, right? Parallelly, you would also subject that version of the application to an abuser-driven model as well, right? You would use the abuser-driven school of thought and the story-driven school of thought for you to find some threats on that model. So essentially, then what you do is you combine both these threats. You combine the threats that the component-driven model is giving you along with the threats that the story-driven model is giving you, and then you have this unique set of threats you're really throwing the kitchen sink at it and getting this multitude of threats that you find from both these schools of thought, and then you start kind of working on them. And what this does is that it kind of solves two problems. One, you're not really depending on the story-driven school of thought for you to scale, because all said and done, the story-driven model is not scalable. It's not a scalable model. It's not a model that you could use for applications that have 100 releases or 200 releases. However, you could use that model to find threat models to ensure that your threat modeling process does encompass within itself very, very specific threat models that are not component related, that are not related to the underlying tech stack, but are related to external factors, or related to how an actor interacts with that application. So all those unique test cases or the unique threat models can be integrated using the story-driven threat modeling. At the same time, the component-driven threat modeling still gives you a platform for you to perform base-level threat models. And what I mean by base-level threat models are low-hanging fruits, the threats that are completely driven through components. So in the projects that we've run threat modeling for, what we've done is that we've usually worked with an external vendor of a threat modeling platform, and we've tried to incorporate the story-driven threat modeling with that platform. So we've kind of made that platform almost work on steroids, if you will, because it does what it does well, and now it's got this additional plugin that we give it as well. So if it's got 150 plugins that the tool runs on, we give it 25 more plugins, and it now runs on 175 plugins, which now gives you the best of both worlds. So this is a very, very interesting way for you to perform threat modeling. And then once you have all of these threats, you can actually integrate that with your security testing framework. And how does threat modeling really fit into Agile, right? And this is usually this is usually a diagram that I depict to show the DevSecOps transformation. What you have on top are the 8 building blocks of any security engineering, of any product engineering process, which is plan, code, build, test, release, deploy, operate, and monitor. And what you have on the bottom are the 5 stages of security engineering, which is threat modeling, SAST, DAST, infrastructure as code, and then security monitoring and attack data detection, right? So these are the very specific 8 and 5 building blocks of product engineering and security engineering. And what the color code really does is the color code kind of tells you how the security engineering processes integrate itself with its respective product engineering processes. For example, threat modeling traditionally, as we know it, has always been in the plan phase, right? Because we've always been looking at threat modeling as just a means for you to find architecture and design flaws, because, and we've seen today, it goes much beyond that. So considering that contemporary or considering the whole traditional model, threat modeling has always been in plan. But now with the, thanks to threat modeling as code and other such initiatives, you're now seeing that orange bleed into the code phase as well. Similarly, SAST starts off with code, runs through build, ends with a little bit of test, and so on and so forth. So the color code of the security engineering process below kind of gives you an idea in terms of how they fall into its respective product engineering process. But what I want to point out to you more here in this slide is the possibilities in which threat modeling can cut across all these stages. So threat modeling can be used in the threat modeling phase, obviously, to model stories, right? So that's the very fundamental use case of threat modeling. You can use threat modeling as a way to derive and drive security test cases. We've seen that as well. So it moves more right as well. What I'm trying to establish here is threat modeling is not just at the far left of the security engineering process. There is a use case of threat modeling in every stage from left to right as well. At the far left, you have modeling stories. Then you have security test cases that can be driven through it. You can now use threat modeling as a way to run security test automation. And finally, you can use threat modeling to actually build detection models as well. Remember the possibility that I told you about being able to link a vulnerability back to your original threat. That is that feedback loop that's possible, and you could build detection models as well. So threat modeling, in terms of just possibilities, and especially for the geeks who are interested in researching threat modeling out there, it's just a case that I want to present to all of you all to say that threat modeling is definitely something that's possible for us to use, not just as just a way for us to find design and architectural flaws, but also as a way for us to kind of work on towards other means in the software engineering process as well. So in summary of this presentation, what I want to leave you with is, please know what works best for you. Like we said, there is no one size fits all in threat modeling. So therefore, it's very unique to an individual stage that they have, an individual product team stage in application security. So there's something for everybody in threat modeling. So therefore, it's very important that the teams understand why they're doing threat modeling. So therefore, you can adopt a strategy that works best for you. It's important and it's recommended that there be a balance between depth and scale, because just going one of these two ways will probably not cut it in the long run. So it's important for us to kind of ideate a threat modeling process that balances the right balance between depth and scale in terms of finding issues. It's important that we make threat modeling more accessible. And what I mean by that is we have to make threat modeling more democratic. It's not just, so what I mean by that, it's not just a process that one team or one set of personas in product engineering use, but we'll need to figure out ways and means in which various members of the product engineering community are able to contribute and use threat modeling to their benefit as well. So how can developers use threat modeling? What does a QA team have to benefit from threat modeling? How can a DevOps team benefit from threat modeling? So making threat modeling more accessible gives you that whole shared responsibility factor as well, especially to QA. this is a separate presentation that I've done, and you can check out our YouTube, the V45 YouTube channel or my LinkedIn profile, and you will see presentations that I've made that talk about how QA is a great way. I don't know, today QA is used as both a noun and a verb, but I'm assuming that if QA is still either, irrespective of whether it's a noun or a verb, QA is a great way for you to integrate security testing within the ecosystem. So threat modeling is also a great way for QA to kind of contribute to the security testing model as well. And threat modeling is ideally done in a sprint, but I want to kind of really not quote that because it's easier said than done. It's important that before we go to a per sprint model of threat modeling, let's try and do threat modeling once a year if possible. Then we'll extend that to doing it twice a year, 4 times a year, 9 times a year, and then you could kind of get it more to a sprint model. Because what companies usually do is they have this utopian dream of doing this only per sprint, and if they're not able to do it for sprint, they have a problem. So let's set expectations accordingly. It's ideal if you do it on a per sprint basis, but like I said, it's an ideal, it's not a practical. But it's always important that we do it as frequently as possible, and therefore we adopt the ways in which we could do that as frequently as possible. Finally, a good threat model is something that's incremental, that allows you to be consistent, and finally enables you to make it as collaborative as possible. So with a good combination of incremental, consistent, and collaborative nature, you can potentially make threat modeling a very, very ideal piece within your software and product engineering process. So with that, I'd like to thank you for the time that the organizers have given me in this year's BSIDS as well. I hope this was useful. This was interesting and added more context to the earlier presentation as well. So if there are any questions, I would be available in the chat window generally, or I have my credentials here, and you could find me on LinkedIn as well. I don't have the LinkedIn ID here, but just Google up my name on LinkedIn. You would find me there. I'm happy to kind of connect with any and all of you and have this conversation forward. So with that said, thank you again for giving me an opportunity to present here, and I look forward to interacting with more people here. Thank you so much and have a good rest of the day.